everyone, I am Vedant and I am going to discuss about normal distribution in this video. You guys are already familiar with normal distribution. Normal distribution, it is also called as Gaussian distribution. It is a probability distribution that is symmetric about the mean, showing the data near the mean or more frequent occurrence than the data far more than mean. So in this normal distribution, we should note down one point that when it is graphically represented, it often obtains a Bell's curve. I will demonstrate a Bell's curve. So this curve obtained is in the form of a bell. So it is called as bell curve. This curve is obtained when we plot the graphical representation of normal distribution. Across the y-axis we are taking probability density and on x-axis we will take mean. Seeing on with the formula, this is the formula for normal distribution. F of x, that stands for probability function. X, it is the value of variable or data that we are being examined. Sigma stands for standard deviation and mu is the mean. Coming on with the application of normal distribution, I will discuss about few real life application of normal distribution. Starting with finance. Finance. You guys are already familiar with finance, what that finance means. So what is role of normal distribution in this finance? There is a term called as price action. Based on that, market analysts decide the price of their products. So they plot price points and fit that price point according to the price action into normal distribution. According to that, they can decide the price of their product. Moving on with the technical stock marketing. So you all know how the stock market behaves. It depends on factors like forex rates, that is foreign exchange rates, price indices and stock prices. Logarithm of these all factors form a bell-shaped curve, and based on that we can analyze the behavior. If returns are normally distributed and more than 99% of these are expected to fall within the deviation of mean value. This might seem fascinating, but it's actually a fact. So based on this analysis, we can cover up how the market is going to behave, and it is going to help a lot of investors and analysts to analyze the behavior. Moving on with the next applications. IQ graph. So what is IQ graph? IQ, that stands for intelligent quotient. There is a test conducted to measure the intelligent quotient. Majority of populations intelligence is considered as mean of it. Anything below the mean will be considered lower IQ and anything above the mean is considered as higher IQ. We can see that on x-axis we are taking IQ square and y-axis will measure the IQ. So this graph demonstrates about IQ curve where we are going to use this normal distribution. Moving further, income distribution. It's more of a government's fact. So what is income distribution? Every income of every country lies in the hand of government. It's up to government that how they are going to use their resources and how they are going to distribute it. So among the population, we can see that there are some rich people, poor people and middle class people. So government will decide that about what wages should be a middle person be receiving, about on what wages should be a rich person be receiving, and what wages should a poor person will be receiving. The wages of middleman will be considered as mean in this type of distribution, and based on that they can decide and plan on the budget of country. So it seems like it has a lot of uses. Apart from these uses, let us consider a classical example of rolling of a dice. When we roll a dice, basically speaking, it is having 1 by 6 probability of all its faces. But when we roll 2 dice, the output changes. So you guys can see over here, this pictorial graph represents that. The probability of getting 2 is only once, 3 is thrice, and so on. The majority of this curve is seen here. The 7 number can be occurred most of the times. So this also obeys the that bell-shaped curve obtained by normal curve. Moving further with birth weight distribution, here also just similar like previous examples. Majority of the babies weight were 2.5 kilo to 3.5 kilo. That is the mean of this curve. Anything below will be considered as underweight and anything above will be considered as overweight. This is the factors that we are going to decide. Lot more than this, there are other sides like deciding a shoe size, deciding about height. There are other factors that also obey this principle. These are our basic usage of this normal distribution. And apart from this, I am going to demonstrate some of this distribution using R language code, and I will demonstrate it in further video. You guys can check that video. The link is in the description. Up to this, thank you for this video. Thank you for watching.